Hello everyone, Assalamualaikum warahmatullahi wabarakatuh. Welcome back again to my lecture video. Okay, so today we are going to look at an example of the force analysis of a Spur gearing. Okay, so please take a look at this example 13-7 here. Okay, so pinion 2 in figure 1334A. This one, okay, this pinion 2 here runs at 1750 rev per minute. So means that this one here and 2 here is equals to 1750 rev per minute. Okay, and transmit 2.5 kilowatt to idler gear 3. This one. Okay, so the transmitted power here is 2.5 kilowatt. The teeth are cut on the 20-degree full depth system and have a module M equals to 2.5 millimeter. Okay, draw a free body diagram of gear 3, this one here, and show all the forces that act upon it. Okay, now this one here, okay, we have a pinion here. So pinion here is the driver. Okay, this one here. So means that, so this gear 2 here will push this gear 3, which is why, okay, if we draw the free body diagram of this gear 3 here, so we have this one, okay, the force that is pushing by this gear 2, okay, which is why we label it as force 2 to 3. 2 3 here means the force from gear 2 to gear 3. This one, okay, this one. Okay, so when we want to calculate the transmitted load WT, okay, WT here is which one? This one, okay, FT here is equals to the transmitted load, WT. When we want to calculate it, because the unit is in SI unit, so we need to use this equation. When we want to use this equation, we have the info of the H, okay, which is 2.5 kilowatt. Okay, pi, we have it, okay. And we have it already, 1750, but we don't have the value of D, D2 here. Okay, the diameter of this gear here, gear 2 here. So how to calculate this diameter here? So as mentioned in this question here, we have the module is 2.5 millimeter. So module, this one, is equals to diameter pitch over the number of teeth. So we have 2.5, this one, the number of teeth. Okay, what is the number of teeth of this one? Okay, the number of teeth is this one, 20 teeth. T here represent teeth. So 20. Then we can find the diameter of this gear here using this module. So which is why when we calculate the diameter of D2 is equals to 50 millimeter, and then the diameter of this gear 3 here, this one, is equals to 125 millimeter. So again, just as a reminder, when we want to pair gears, we need to make sure that the module of the two gears is equal to each other. Okay, which is why we have the same module of this one and also this one. So we have the value of diameter already, this one. So we just insert the value into this equation here. Then we can get the value of WT is 0.546. Okay, so this one here is equals to 0.546. Okay, so how to calculate FR? This one, this one, the radial force. Okay, so the relation of this one here, okay, this one, also this one here, if we put into a tangent, okay, this one, a tangent 20 here, the angle is 20, is equals to F, this one, F R over F T. Okay, so this is the relation, because we have angle here 20, so tangent is this one over this one, so FR over FT. So because we have the value of FT already, okay, 0.546, so we can calculate FR is equals to Ft tangent 20 here. So as mentioned here, as shown here, so we insert the value, so we will get the value of Fr is 0.199 kilonewton. Okay, so this one here is equals to 0.199 kilonewton. Okay, so how to calculate this one, F23 here? Okay, because we have the angle 20, okay, and we have the value of Fr and the value of Ft. So then we can use this one here, as mentioned here, they use cosine. Okay, actually you can use anything, cosine or sine, either one is okay. Okay, so what is the relation of cosine angle here? Okay, let's erase the tangent first. Okay, this one first, erase this one. Okay, so cosine, okay, cosine 20 here is equals to this one Ft, this one over this one. Okay, so Ft here over F23 here. Okay, so then we can calculate F23. We bring F23 to the right side, to the left side, this one to the right side. Then when we calculate, the value of F23 is 0.581. Okay, this one 581. Okay, now we got all the values of the force in tangential force, radial force, and also this one. Okay, the force of this one. Okay, what about this one here? Okay, the force of this gear C here. Okay, gear number 3 here, and this one. Okay, gear C here. So because this one here, okay, gear 3 here is an idler gear. Okay, this one here. So means that the transmitted force here, okay, the tangential force here, is actually equals to this one here, the tangential force of this gear here, this one. Okay, so because it is equals to each other, so means that this tangential force is equals to 0.546. So because tangential force is equals, the angle also same, 20. Therefore, the radial force will also equals to this radial force. Okay, so this one here will be 0.199 also. Okay, now the value of this one and this one, okay, is we already know. What about this one, F43? Because all the value is same, angle also same, means that F43 is also equals to F23, which is 0.581. Okay, okay. So before we proceed any further, let's this one erase this part, the one that we don't need anymore. Okay, now we have all the values on this gear 3 here. Okay, so what about the value of the reaction force? Remember, we've talked about the reaction force. When we have an external force, because this thing is in static position, not moving or anything. Okay, so it means that we will have a reaction force, okay, in the middle here, which is related to this external force. Okay, as mentioned in the previous lecture, so this one, the reaction force here will have the same magnitude but opposite direction. Okay, how to calculate this force here? Okay, so because we want to make it in static position, okay, the total of force, okay, the total of force must be equals to 0. Okay, so this one is in static, static lecture. Okay, so because the force is equals to 0 and we don't know the value of Fx and the value of Fy, the reaction force, the one that we want to find. So the total of force in x direction, okay, will be Fx. Okay, so this is the force on the shaft here, and then we need to plus with this one the force of this one here. Okay, the x direction here is Fr here. So F radial for 3. Okay. And then this one. Okay. The x direction of the another force is this one. F tangent to 3. Because the direction is in negative direction. So this one must be negative F tangent to 3. Okay. And the value, the total force here is equals to 0. This one. Okay. So, this one we know the value. Okay, which is 0.199. This one also we know the value, 0.546. So when we calculate the value of fx here, this one, fx, okay, is equals to, so because we move everything to the right side, so we have negative this one, f tangent plus this one here, so negative 0.546 plus with 0.199 here, and the value is 0.347. Okay, so this is for x direction. Okay, what about the y direction? So the total of force in y direction must be equal to 0. Okay, so we have the unknown force, which is the Fy, and what is the direction of the y? Okay, y we have this one. Okay, so this direction here is in negative direction. So negative F tangent for 3. Okay, then this one, okay, is the another force that is pointing towards y direction, which is Fr to 3. So positive Fr to 3, okay, equals to 0. So this is the force equilibrium. Okay, this one here. So because we already know this value here, Ft for 3 here is what? This one, 0.546. Okay, this one here is 0.546, and this one here is 0.199. Okay, so when we insert this value and we calculate the value of Fy here, this one, we will get the value is 0.347 kilonewton. This one. Okay, so this is the reaction force in x and also y direction. Okay, this one and also this one. Okay, and this is the resultant force, means that the summation of this force plus this one here, this one, the resultant force here. So to calculate this one here, we can use this equation, okay, which is this one is equals to square root of fx square plus fy square. So which is fx square plus fy square. Then square root, and the value is 0.491 kilonewton. Okay, so this is how you calculate the force of a gear. This one. Okay, so if you have any question, feel free to ask me. Okay, bye bye.